as functional or active components. So 3D printing is generally to say simply that it is a process to convert 3D objects, 3D models, into physical objects. And then there is a specific procedure, obviously, to achieve that feature. And another thing that we can see is that obviously that when we talk about additive manufacturing, it is on the opposite side of traditional manufacturing that usually works on a means of subtraction. So additive, it obviously means about adding materials. And the common thing that connects all the technologies in this umbrella of technology is about that we basically decompose, let's say, the object through layers, through a stratification. So in this little diagram we can see the process now in steps. So we have an object, so we have a 3D object in our CAD system. Then we have software that creates the subdivision, the slices, so it slices the object to create basically the code, the G code that we use to inform the machine for the production. And generally the G code is generated according to the type of machines that we are going to use. And at the end we have the final product. We can use that for prototyping, and we usually do so. But again, can we use those techniques for end-use products? So SLS, it's also a technology from the 80s. It's basically laser sintering materials that are in the form of powders. So basically you have two bags, one full of powder, material in the form of powder, the other one is empty. And then basically the material is distributed to the other bag and then sintered through a laser to, again, with the same principle, so layer by layer, to slowly form the entire object. This technology is really intriguing because at the end of the production process, you're like an archaeologist that you dig into the sand or to the powder, sorry, to take out the material. And the advantage is that in this case you don't need support. So basically what you can print hollow structures precisely because the powder is supporting by its own the material. In terms of materials, usually as you can see in the picture here, we use nylons, and we have different kind of nylons like PA11 and PA12. One is bio-based, the other one is synthetic. It's a matter of let's say deciding. They have different properties, mechanical properties. So according to the need and the use, one is better than the other. And again, if we talk about the hype that I mentioned before, so around 10 years ago, we as a community of designers, let's say, developed a project like in this case here of chairs or armchairs using SLS. And obviously, yes, it's fascinating, still far from being used, let's say, as a technology to produce and manufacture real chairs that we can use in our houses. But again, it's an exploration that we have to do in metal printing. So one of the most diffused technologies in metal printing is DMLS. So that is direct metal laser sintering, and it's very similar to SLS, so it's metal in a powder form that is then fixed in its bounded box, always layer by layer. And what we have at the end is what you can see here. So again, you have to dig into this box of metal powder to merge, to let the pieces emerge. Then according to the different technology, we can have different post-treatments. And again, many designers, or some designers actually explore the way of using this kind of these technologies, metal printing, to make furniture designs like this piece, this aluminum graded chair by Joyce Larman, where the interesting part is obviously the use of the material and the form as well. So the combination of form and material. So so that you have this cellular structure that is saving material, so you have the material only when you need, you have the densification of material when you need, and so on. Okay, it's amazing, wonderful, but again, there is the downside in the sense that there is a lot of labor behind this kind of product. It's still, it's not only printing, again, as I said, it's not just pressing a button and then you have the final product. Also because of the size. When we talk about interior design, probably we think about furniture, we think about panels and so on. And the size of the product is much more, it's bigger than the average size of the MLS in this case. It comes with machines that have a bounding box that is about 40 by 40 by 70 centimeters. So if you have to build an object that is larger than that, what you have to think is how to fraction, how to divide in pieces, in chunks, the whole piece. And so then you have to think about the assembly line. So how to recompose the object at the end of the fabrication. Again, as I said, for the SLA that is used heavily, let's say, for small object and rapid prototyping and so on, SLS could be used again for small items, like in this case. And it's very effective when we use it also for these translucent properties that have the material the nylon has. So we have here these examples of beautiful suspension lamps that are made by this technology. Again, something about 2010, something like that, by freedom of creation, one of the pioneers of the field. Another, let's say, realm where this technology could be used is this kind of on-the-core, let's say, possibility, in the sense that we have, again, SLS works with small format. We have machines that are not, that don't allow us to have large pieces. So what we can do small items that are actually customizable. So it could be bespoke socket, like in this case, or color. And I think that SLS, in this case, it's worth to be used. Then, talking about, so we talked about two technology, SLA and SLS, that uses one resin, the other one nylon materials. So they have different mechanical properties, obviously. So I didn't mention, but the SLS for instance, the nylon can have a very elastic material, so we can use that properties in our, let's say, design. But then, there is another field that is the one called metal printing. And the field of metal printing that is under the umbrella of MAM, so metal additive manufacturing, is actually very wide, I would say, also. In the sense that we have a lot of technologies to manufacture using metals. The thing that I have to say, metals nowadays are really high-hand, metal additive manufacturers for high-hand use, and for use a lot in aeronautics, automotive design, for sport cars, and this kind of needs.